Okay, chapter 4. Let me zoom in a little bit. It's easier to see when I do that. Chapter 4. Oof, that means we're going to have 3 tests done soon and 1 to go, the final exam. Yeah, that's right around the corner. I'll give you the day for the final exam, etc., but we're not quite there yet. Let's take care of the chapter 3 test and start to get working on section 4.1. All right, as always, you see a lot of words. One-to-one function. A function f is a one-to-one function if for a and b in the domain of f. If a is not equal to b, then f of a is not equal to f of b, or equivalently f of a equals f of b, then a equals b. Okay. Can somebody put that in English? I think I can. In order to be one-to-one for every x, there is only one y, and for every y, there is only one x. Okay. So let's take a look at this first group of numbers to see if they are in fact one-to-one, because this is going to be a setup for something to find what's called an inverse function. And this is another building block. For example, in my trigonometry class, we got ready to work with inverse trig functions. And I said, everybody should have the concept of inverse functions down so that you can build upon it and work on what we were working on that day. And some folks were like, oh boy, I didn't really know. Yeah. Okay. So it is a building block. For every x, there's only one y. If I say 2, the only y value that 2 has is 1. There's not another ordered pair out here, 2, 6. If there was, it wouldn't be one-to-one, because 2 has a y value of 1, but 2 would also have a y value of 6. And yeah, no, we don't want that. 4, x value has one y value. 7, x value has only one y value. So I search through these other ordered pairs, I don't see it. And I'm thinking, okay, so it's a function. Every x has only one y. And I'm going, yay. But then in order to be one-to-one, every y only has one x. I say 1, you say 2. Uh-oh, wait. I say 1, it maps to -2. So this is not one-to-one, not one-to-one. And the reason is I have y's that go to different x's. So this is like an advanced level of working with ordered pairs and graphs and lines. This guy is in fact one-to-one. I say Batman, you say Joker. And if I try to go in reverse, nobody else has a nemesis that's the Joker other than the Batman. So Joker's nemesis is Batman. It would go backwards to one spot. Green Lantern goes to Sinestro. Sinestro goes back to Green Lantern. Wolverine goes to Sabretooth, his brother. But I think he beats him up on 3 Mile Island. We all know where 3 Mile Island is. And Sabretooth's enemy is Wolverine. Okay, so yes, this guy is in fact one-to-one. A function is said to be one-to-one. Oh, sorry about my arm. If it basically passes the horizontal line test, but also passes the vertical line test. Okay, we know the vertical line test. That's this one. As I move across, every x has only one y. And if I look, if I said -3, you only have one y value. If I say -2, there's only one y value. So the vertical line test, vertical tells me that it is a function because it passes the vertical line test. Now, is it a 1-to-1? Well, if I look at my y's, there's only one x, there's only one, there's only one, there's only one. Yes, so horizontal tells me it's 1-to-1. Einst und einst. 1 and 1. 1-to-1. 1 and 1. I have basketball in my mind. Let's go Carolina. Nina, are you rooting for Carolina or Duke?
I don't know. Neither, I guess.
Neither. It's Friday night. You're not going to be, or Saturday night. You're going to be busy. You're not going to watch the game. All right.
I'm not.
Once again, thanks for having your screen on. Number 4, is it a function? Does it pass the vertical line test? Does x have only one y? The answer is yes. Is it 1-to-1? If I take the, yeah, no. Horizontal line test, not 1-to-1. This one was, because every y only had one x, right? Every y, but this one I pick a y value and it goes multiple places. And again, you see the trig. Number 5, function. Somebody tell me yes or no.
Yes.
No.
Yes, it is. It passes. It looks a little funky there in the middle, but it passes the vertical line test. Every x value I give you only goes to one y value. Is it 1-to-1? Does it pass the horizontal? Remember, the sun sets on the horizon, and the horizon, here's the horizon. There's the sun setting. Yay! We're not going to see it today. Maybe the sun will be a little. It sets on the horizon. That's the horizontal. Okay. Yeah, it is 1-to-1.
Yes, it is.
Yes, it is. Good. Very good. Very good. Very good. Use the definition of 1-to-1 function determinant. Oh boy. If I give you an x, you would give me a y, right? If I say 1, you would say 5. If I said 2, you would say 8. By the way, if you want to jump in real quick, hit your space bar and hold it down. That way you unmute quickly. So you hold that space bar down. If I said 1 again, it's still only giving me 5. No matter what number I put in, it's going to go to that same. If I say 1, it's still going to be 5. If I say 2, it's still going to be, it's going to go to a unique number. And in reverse, every y would only have one x. So this one's good. This one's not. It's a function, and we're experts on graphing. We know it's x squared, but it's going to be narrow. And if I draw it, it does pass the vertical line test, but I don't see it passing the horizontal line test. If I say 1, you would say, hold that space bar down and give me an answer.
-3 and +3.
Now it's just going to give me one answer here. So this is going to be y equals. If I put 1 in for x, just do that. You're jumping ahead a little bit. I say 1,
3.
you say 3. If I say -1, now you would say,
-3.
well, now it's still
+3.
+3, right? So yeah, you can see it does pass that vertical line test. But when I go to do the horizontal line test at 3, I'm going, uh-oh, I'm hitting 2, not 1-to-1. Not 1-to-1. Okay. Cool beans. Easy page. Y'all are like, yeah, it's easy page. Okay. So here is a little trick to find out if a function is one-to-one, okay? If it has an inverse function. So that would be, here's my function. Who is their enemy? Would be from Batman to Joker. Okay, or who's the bad guy with Batman? Joker. The reverse function would be who's the good guy with Joker? Batman. Bad guy to here, good guy to there. Okay, so there's a function that gets me over here, but now an inverse function is one that would get me back. So if I take a look at this very first one and I pick the value, like 1, 3 times 1 is 3 plus 6 is 9. If it's an inverse, that means if I pick 9 and plug it in, pow, I get 1. Once again, what I'm saying is I'm going to have a group of domain values here, 1, and over here is range values, and there's 9. And when I say f of x, it takes me over there. And some of you are starting to go, oh, I kind of remember this kind of stuff. And then if I go here to get back over to 1, what's that function that gets me back to where I started? And that function in this case is g of x, but we're also going to write it as f's inverse. We're going to see it written like that. So instead of g of x, I could have wrote the inverse function, the inverse of f. And then I pick another number, 2, I get 12. So 2 here goes to 12. If I put 12 into the second function, I do in fact get 2. Gets me back to where I started. Okay, got that. Now, what this is saying up above is, do you remember doing composition of functions, f of g? We did something along the lines of if f of x equals 2x plus 1 and g of x equals x squared, if I said f of g of x, I was saying, yes, I do recall that was f of g of x, which means I could replace this with x squared. And then in my f function, f of blah equal 2 times blah plus 1, which means if I want to put x squared in, this would become 2 times blah x squared plus 1. Okay, it was the composition of functions. F of g of x was the same as f of the function g of x. Take that out, put it in, and go from there. Think of f of blah. So x squared goes here and here. Well, this is kind of cool what happens with these bad boys. If I said f of g of x, and I said, okay, f of x is 3x plus 6. So f of blah equals 3 times blah plus 6. Now, g of x is 1/3 x minus 2. So this is going to equal f of 1/3 x minus 2. That means when I come to my function, it's going to be 3 times the blah, 1/3 x minus 2 plus 6. Oh, nice. X minus 6 plus 6 equals x. So that's how I know if two functions are inverses. If I take x, plug it into g, that means I went from here to there, right? Because I plugged it into g. And if I then plugged it into f, it takes me right back to where I started, whatever that original x was. So if I plugged 4 in here, the answer would be 4. If I plug 4 into this, get an answer and plug it into this, gets me back to 4. Okay. Donna. F of G of X equals F of G of X, composition of functions equals, I'm going to let you see if you can work that the rest of the way through while I enjoy two nonpareils, because I love nonpareils. I'm sure some of you enjoy the nonpareil as well. My F function, F of blah equals blah plus 1 over 5. Hope, are you here today? Daniel, are you here today? Abby? Jandy? 13, 14. Somebody's here and they're not telling me. All right, let's see. Is there a Hope? Nope. Is there a Daniel? Nope. There's no Peter. There's no Abby. Somebody's here and they're not telling me. All right, bear with me for a minute, folks. Andy's here. I figured it out. No, let's see if I plug that in. I'm going to get my blah is 5x plus 1 plus 1 over 5. That equals 5x plus 2 over 5. Uh-oh. This should have ended up equaling x, and it did not. It did not, because this should have. So if I pick a number like 4 and I plug it in here, I get 1. But if I plug 1 in over here, it doesn't give me 4. It actually gives me 6. So these two guys are not inverses. I can't start at 1. I can't start at this domain and end up at this range value. Lingo you learned a long time ago. And then make this my domain and this become the range and get me back to where I started. Every case over here will work. Not every case here will work. All right, so what if I said, okay, well, I really, this f of x, which I'm going to call y, I'm going to replace with y, equals x plus 1 over 5. And I'm going to say, I wonder what? Oh, I wonder, oh, you can't even see what I'm doing. I wonder what the actual inverse is here. Because when I looked at this one, it didn't work. This was not its inverse. But can I find an inverse? That's a great question you just asked. Whoever asked that question, 1 point for Gryffindor. Nice job. Okay, so I want to find the inverse function. And here's how I do it. I'm going to switch the x's and y's. X equals y plus 1 over 5. And then I'm going to solve, then I'm going to solve for y. I'm going to multiply by 5. I'm going to subtract 1. And I now know that that's my inverse function. Right there it is. So if I came up here, put in the value 4, 4 plus 1 is 5, divided by 5 is 1. If I put in 1 here, pow, I get 4. Again, if I took my function f, if I put in 4, oh, that just worked out. I get 1. If I took my inverse over here, this time I want to take the 1 and I plug it in, I get 4 out. Yay! 9. If I put in 9, I get 2. Down here, if I put in 2, I get 9. So in order to find something's inverse, I switch the x and y. Cutting edge here, folks, cutting edge. Ooh. Start to take a look at the graph. So 1-to-1 function is given. Write an equation for the inverse. Yes, I know that it is 1-to-1. It passes my vertical line test. So it's a function. It passes my horizontal line. So it is in fact 1-to-1. What is the inverse function? Set it equal to y. Switch the x and y's. Solve for y. That will be your inverse. That is some high quality H2O. All right, so he said we're going to switch 2 plus 1/2 y equals x. X minus 2 multiplied by 2, y equals 2x minus 4. So that is now my inverse function. I said, whoop, there it is.
So there I'm confused here. Are we gonna directly replace x with y without solving it?
We're going to swap them right here.
Yes, yes. Mm-hmm.
And now I'm going to get the y alone. I'm going to solve for y. Subtract 2, multiplied by 2. So now that's saying if I took values up here and plugged it in, if I plug in 2 and 4, that means down here, if I switch the x's, okay, if I plug in 2, I get 3. If I plug in 4, I get 4, which means down here, if I take those range and make them domains, if I plug in 3, I get 2. If I plug in 4, I get 4. So again, you see how the x's and y's are switched.
Yes.
What went from here went over there, and what was over there came back to here. So we were able to find an inverse function. Cool beans. Oh. What if I graph this, right? My y-intercept, 1, 2, 3, 4, is at -4. My slope is 2. My b equals -4. My slope equals 2, or 2 over 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I get this line. That's its inverse. That's its inverse. Now, something that's really cool about inverses. If I drew this line right here, that line right there is called y equals x. The points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, all the y's equal x. But what do you notice about this graph that we were given starting with and this graph, our red line. What do you notice about those? S word. S word. I didn't do my Wordle today. I have to do my Wordle. Guess a letter. Wordle. Hold that space bar down. Nina.
I.
I. S-Y-M-E-T-R. Might be too many. We'll go with that I. Good. Give me another letter.
E.
E. S. Symmetrical. How do you spell Nina, how do you spell symmetrical? S-Y-M-M-E-T. Maybe this is the I. I'm not good at this game. Yeah, it is. In fact, it's symmetrical. It's symmetric. We have a line of symmetry. What that means is it's symmetrical. I can flip over that line. It has symmetry over that line, y equals x. Okay, so if I know the graph of one, I can pick points and do the graph of the other. It's kind of cool. Oh boy. I want you to tell me what the inverse is. Who is Batman? No, what is the inverse? Take a couple seconds, see what you can come up with. Walk me home in the dead of night. Na, 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 na. We're going to say this equal to y. And then I'm going to switch the x's and y's. Mm, 3y. Oh boy. Y plus 1 equals x. Scholarly students, where are you? See if you can get this. This is a tough one, but it's one of those once you see how to do it once. Yeah, you know, okay, yeah. Help me out. How do I do it? I hate denominators. I shouldn't say hate, that's a strong word. I'd like to clear my denominators. X times y plus 1. We good with that? That's not so shabby. Not too bad. 3y equals xy plus x. Okay. I think we're getting closer, believe it or not. Looks pretty ugly. I know I only want one y, so I'm going to get the y's together by subtracting xy from both sides. The more we get together, more we get together, the
Happier will be.
Thank you, Nina. Thank you, Jesse. Yeah. Okay, I'm still rolling here. Factor out a y. 3 minus x equals x. Oh, divide. Y equals x over 3 minus x. Huh. And I need to test this just to make sure. I'm going to pick a value, and whatever value I pick, it's going to be ugly. Let's just go with a 1. I say 1, you say hold that space bar down, Emma, and jump in anytime you want. Emma, Ella.
It would be 3.
3 over,
Oh, 2.
yeah, 3 over 2. So that means if I came down here and said, oh, this is my inverse function, I throw in a 3 over 2 and do some algebra here. I don't use these again. If I throw in, that means I get 3 over 2 divided by 3 minus 3 over 2. Oh, this was a building block I had to learn somewhere along the way. I'm going to multiply everything in the top by 2, everything in the bottom by 2, because that's like multiplying by 1. This guy becomes 3 in the numerator because the 2 cancels. In the denominator, I'm going to get 6 minus 2's cancel again, 3. That's going to equal 3 over 3, what equals 1. And I go, yes, that's what I wanted it. X went to Y. The inverse said, take that. Now make it your X. It goes back to where we started. Oh yeah, pat myself on the back. I'll be celebrating this over a malt beverage tonight, just so you know. Zima. You folks don't know what Zima is. I'm just kidding. Oh. Oh boy. Oh boy. Do it again. What do you get? I'm gonna come over here and play and go, yeah, no. There's my symmetry line. We talked about this, right? And at the point 0, 1, 2, 3, if I switch it, 1, 2, 3, 0. Let's see. Oh, here looks like another point. 1, 2, 1, 2, 3, 4, 5, 6, 7. So now I'm looking at the point 2, 7. That means 1, 2, 3, 4, 5, 6, 7, 7, 2. And I'm going, I know what the final answer should look like. And we'll talk about it in a minute, but okay. All right, so I'm going to set this equal to Y. Y equals X squared plus 3. Switch. X equals Y squared plus 3. Woke me home in the dead of night. I wish I could sing. I just can't. Anyhow, I get that. And I'm going to take the square root. And when I take the square root, shouldn't I get plus or minus? Yeah. But looking over here, I noticed, ooh, there's a restriction on the domain. Because if I didn't, this graph will go, yeah, and it would be a function, but I couldn't take its inverse. What? If I just said X squared plus 3, here's the graph, it would go up like that. This graph, X squared plus 3, is a function, vertical line test, but I can't find an inverse. It's not going to be 1 to 1. So what I do is say, well, this is only going to be for the X is greater than 0. So none of this exists. So when I get ready to do the inverse, when I take the square root of both sides, I only want the positive square root. And I also know, yeah, my domain is for X is greater than or equal to, don't look at that, 3. Tying some things together. What's the domain for the square root? Well, there's the graph. It's, yeah, here's Y equals X. Lots of pieces coming together. Different things you've done in math. The more you learn, the more you can learn. Oh, I should make that my coin phrase. The more you learn, the more you can learn. No. No. Okay, let's see what we have here. There's that line Y equals X. Graph the function, or here's the function, graph giraffe. No, I didn't say giraffe. Graph the function. How do I find an inverse? I switch the X's and Y's. What I just did on the problem before, I picked a point and switched it. So this is the point 1, 2, 3, -4, -2. So that means -2, -4. Oh yeah, I see it. I flipped it over that line. This was -4, -2. This was -2, -4. Okay, cool. 1, 2, -3, +1, +1, -3. Yeah, no. -1, +2, +2, -1. Yeah, no. Uh-oh, did I mess something up here? -1, +2, +2, -1. This is 1, 4, 4, 1. Oh, looky there. Who's bad? I'm bad. Oh. Questions? Questions? Some of you have to take trig. Don't lose this worksheet. I'd hang on to it. And so ends section 4.1.